This is our second lesson on vectors, and again, we're following on from our introduction of vectors. So today we're going to be looking at direction vectors, and in the next video, we're going to be looking at how we use vectors to solve problems involving geometry. So a direction vector is a vector that differs slightly from a position vector. It is a vector that goes from one point to another on the plane, but it doesn't start from the origin. It might go from 2 points, say A to B. So here are our examples. Firstly, we're going to find the vector AB, where AB is a direction vector because it starts at the point A, which is 1, 3, and ends at the point B, which is the coordinate point 4, 2. Now, there are two methods of ways to work, I guess, with direction vectors. So I want you to choose the method that works for you, but know how to use both. So the first method is the most straightforward method. We simply start at A and go to B, and we write our column vector. So our first component is how far across do we have to go from A to get to coordinate B. If we look at our diagram, we see that if I start at A, I'll need to go 3 units to the right to get from x equals 1 to x equals 4. So my first component in my vector is 3, and it's positive because I'm moving right. Again, to look at the second component, we just look at the change in y. So how much do I have to move and in what direction to go from y equals 3 at A to y equals 2 at B? And of course, I'm moving down 1, so that will be a negative component of value 1. The next method that we're going to try is we're going to use the vectors we already have in our diagram and either add them or subtract them to end up with our vector AB. Can I start at A and I can go back down that vector OA, so in the opposite direction to the origin. And then I can go from the origin up along vector OB to get to my point B of 4, 2. So this method, I'm just going to use vector addition. Notice if I'm starting at A and going to O, this is vector AO. So I have vector AO plus OB. Vector OB, we know that's 4, 2. And AO, so remember to start at A and get to the origin, I'm going to go -1 unit across or 1 unit to the left, and then again down 3 units to get to the origin. So -3 will be my second component for vector AO. Notice this is the same as basically timesing OA by a negative, because remember that negative just makes our vector in the opposite direction that it originally was. So let's compute it this way. I'm going to take AO and then add vector OB to the end. AO was the same as negative OA, so I'm going to write that in there. -1 minus 3 plus OB was 4, 2. If I add these together, hopefully I get the same answer as I did using method 1. And we do. Question 2, we're going to do the same thing, but this time find vector BA in the graph. I'm going to use the same methods just to display them, but notice that BA is just going to be the negative of AB. So you could simply times AB by -1 and we should get BA. But let's do it the two methods that we used before. We want to start at B and go to A. Okay, the change in my X Going from x equals 4 to x equals 1, so I'm moving 3 units to the left. That means my first component will be -3. The change in y, remember we're starting at y equals 2 and we're going up 1 unit to y equals 3 to get to a. So that change is +1 for my second or my y component of the vector. And notice this is indeed negative of AB. So to start at B and go to A using the two vectors I already know, I can go down vector OB, right? So in the opposite direction of OB until I get to the origin. Then I can add on this time vector OA, starting at the origin and ending up to A. Okay, here BO, remember that will be just negative OB, and OA, well, we know what this is. BO plus OA is the same thing as minus OB plus OA. Okay, OB we had from above was 4, 2. So minus OB will be -4 minus 2. And I know OA, well, remember that's just 1 unit to the right and 3 units up. So that will be 1, 3. If I add these together, voila, we're going to get -3, 1. Okay, so now it's your turn. If we have the point A, 2 minus 3, B, 5, 0, and C, -1, -1, and O is our origin, we need to state and sketch the following vectors. Vector O to A, vector A to B, vector C to B, and vector C to O. Once you've drawn in all your coordinate points that the questions asked you to, let's begin by stating and sketching the vector starting from O and ending up at A. This one's quite straightforward. I'm going to draw it in red. So the sketch is done. Now all we have to do is write out the column vector. So I know if I'm starting the origin and ending up at 2 minus 3, I'm going 2 units right and 3 units down. So my column vector is 2 minus 3. Our next job is to find vector AB. I'm going to draw this in green. OB is 5, 0 as a vector. We're going 5 units to the right, but no units up or down. I also know that OA is 2 minus 3. These might come in helpful depending on what method you use to find AB. I'm going to do it in both ways. So let's start just looking at the change in X and the change in Y. Well, I know to go from X equals 2 to X equals 5, I'll be going across 3 units to the right. If I go from -3 equals Y to Y equals 0, that is 3 units up. Simply 3, 3. Then try it the other way. So we could start at A, go to the origin, and then go from the origin to B by my vectors AO plus OB. AO is just negative OA, and we know that OA is 2 minus 3. So negative OA will be -2, 3, plus on OB, which was 5, 0. Hopefully we get the same thing that AB is 3, 3. I'm going to leave it here for you and you can try CB and CO but I will just put up my solution to those right now.